Welcome back. And well, we're going to do it. Where that is the last time we spent a long time getting Bison and Flex set up to work with C++. So we've got reentrant code and or reentrant parsers and everything like that. And the goal for today is to be able to actually compile. I don't know if we'll get to execute, but we'll see about that. Um, Something. I believe we had a three before, or I think that's what it was. But anyway, okay, there's something in the corner now. It's going to drive me crazy because I don't know what it is. Oh, it's just part of my mic. Sorry about that. It was bothering me. Anyway, okay, so we're back. And but before we do this, let's see. There's some stuff I wanted to show you. So I added documentation, and if I can go to, let's see, let's look at the includes and perhaps the AS. Oh, CD, no, just Vim. Include AST because I'm putting all of the documentation in the .hpp files because that's how I like to do it. And you can see here, well, unfortunately, evidently 80 columns. You know what? Let's fix this. Let's change the size ever so slightly smaller. And we'll go for size 28. And that is maybe a little too small. Let's go with 32 and see if that gets us, we're on 75, 76, 77, 78, 79. It's just barely. So I'm going to go 1 point smaller. 31 pixels on this screen. Is that right? Did that do it? I don't think it gave it to us. Nope. Maybe it needs to be 30. That's probably going to be it. Say, why do you stick with there? Well, it'll be right there at the end. That should work out fine. No, just undo all those changes. Okay, so you can see here I added documentation to the like the class name, and then for each I made the constructor for the AST node protected. The idea being the AST node should never be called by itself. It should always be an AST node of an integer or of something else. So yeah, so I just made that protected. But everything else, like for these constructors, giving the parameters, describing the different variables involved. And now let's see what the result of that is. And the result of that is we can do WSL view, and it's under docs, HTML, and index, of course. And there we go. That opened. Let's just make it big. There we go. Actually, I don't want that. We'll put it over here. Yeah, so if we go to AST, the classes, I'll just click on class list. There we go. So AST node, it has its documentation, or the node integer, it has its documentation. And we set it to inherit documentation. So for example, this inspect, which we haven't even, I don't think we implemented that yet, but anyway, the documentation here on the AST node integer uses the documentation from the parent function. So if you don't redeclare your documentation, it just inherits the old one. That was one of the settings in Doxygen in the Doxygen configuration file that we enabled. And then I want to point out something. One of the reasons that you write good documentation is actually what we benefited from, and you might not have caught it before. And that is here, if we look at the location variable. This was defined in location.hh and in my command. So if we go to, don't know why that just changed size, but if we look at the make file and we go down to where we did the docs, there we go. Oh, it's in the Doxygen setup. Sorry. Doxy file and where I tell it. Oh boy. What I'm looking for is where I tell it which directories to include. I know it's here. It's I should just use page down. There we go. This line right here, 864. The input is equal to, and I told it to look in Bison and Flex, which I probably didn't need to tell it Bison and Flex, but in the include directory, the source, the test, and then the build. I told it to look specifically for this location.hh. And if we go to that, actually, oh, it's I guess it's still here. Generated, and then location.hh. I'm going to open it, and it says, yeah, this was all generated, but look, it has information. When you see the /**, that is information that is in the Java doc format that Doxygen reads. And in other words, what I'm trying to say, and by the way, the // is also a Doxygen coding. For you're telling Doxygen, hey, I care about this. So for position, it says it is a point in a source file. And if we look at position here, it says a point in a source file. There we go. And we go to more. I think that's all it says. I don't think it. Oh yeah, the detailed description down there. A point in a source file. But for each one of these, they wrote in documentation, and the lines, for example. Let's see. This is under. Oh, I think that's under location. Lines. There we go. And it's under a section called line and column, and there's a documentation for lines. And anyway, the point is, what I'm actually just trying to get to is the fact that realized by someone else doing good documentation, we're benefiting from it. And that's what we want to do. That's why I put the documentation in the .hpp files, because if someone includes them and says, give me the documentation and point it at the directory that includes our .hpp files, then it will, they will benefit from it. That's the point. A lot of IDEs can also understand Javadoc syntax, and they will provide good help. I'm not using an IDE. I'm using Vim. That's the only IDE a real programmer needs. No, not really. But yeah, a lot of IDEs will give the programmer help just by doing that. And the only thing I haven't done is, so if we look in the files, location.hh actually had a file directive. We can see it actually, where's it going to be? No, that's the bottom of the file, the top, there we go. And it says, this is my location, and this is what we're doing. And that's what it says. But I have not included that yet for the other HPP files that we've created. And if I click on this, notice it will, I was thinking it would show us, oh, go to the source code for this file. And it shows us the source code minus the java.doc comments. Those are stripped out. But yeah, we want that for ours, so I'm going to add file directives. Haven't done it yet, but it's coming. I'll tell you when I do. All right, so let's get back to what we're trying to do, and that is we need to do a couple things. I need a test program that I can just test something. So let's start off with saying the make file. Oh, I'm in, that's why. So in the make file, what we're going to do is, yes, I just changed my mind about where I need to look. In the app directory, okay? So copying that. And this is going to be the tests, okay? And actually, let's just steal this one. And its name is not target, but you know what? Just test. Test. And it is going to rely on test/test.cpp and the app directory /target. I think that's right. Compiling, we'll just say test. And what's it going to look like when we compile? It's no longer a shared. The output's definitely going to be this. You know what? I'm going to cheat. I'm going to look at, I'm doing my makefile differently than I had before, but it's similar enough that I can at least double check my makefile. Oh, and I'm going to call this unit tests, even though it's not technically a unit test yet. I probably need to include the includes. So if in my test I #include something, that would work. $@ that's the output. This should yeah, this should not be the caret. This should be the less than, which means this file. And then what did I do there? Oh, okay. So we're going to add one more. So the lib objects, and now, oh wait, nope, Tang library, I already have it. What line was I on? 88, something around there? Yeah. Did I just put it at the end? Tang library. Not capitals, there we go. That should work if I now say make. Didn't mean to quit yet because I want one more phony rule called, I'm trying to keep these in alphabetical order. So let's go with test, and down here it's not necessarily in alphabetical order. And it needs to make all, wait, is that right? No, I can do, we'll give this the, sure, make and run the unit tests. Okay, and now okay, that should be a tab. It is. And all that we're going to do is after we have run it, we're going to say dot slash you know what? We can do this. That should work. Now, it doesn't exist yet, but if we type in make test, no rule to make because test/test CPP does not exist, which it's because we're about to make it now. And so test.cpp, and we're going to have a pound include tang.hpp. Doesn't exist yet, but we're about to make it. And all that I want is an int main return 0. Very, very simple. And we're going to make that pound include. So include tang.hpp, and just for the moment, all that it's going to do, I need to list these out. There we go. Tang base. Do I need Tang scanner? No, I think that will be hidden. Not hidden, it's just more internal use. So I think that will work. And now if I make test, it compiles and it does nothing, but it doesn't give us any errors. So that's always a good thing. All right. Now, what is this going to look like? I gave an example program of what I kind of envisioned it looking like to work with Tang, and I need to get to GitHub, and I'm probably auto completed. No, how dare someone else use my name? You know what? I could just search for my own name. There we go. Yeah, there's me, the Colosseum in Rome. Where's Tang in this? A lot of old stuff. There we go. And was I looking? Oh, yes. So giving kind of a simple example of how I kind of hope it would be used. The problem is we can't do all this fancy script, but I can at least do this. Let's do this. Auto program is equal to so I've got this idea of having a compile script and why am I doing this? Because then it just lets me put in some it's a nice newer, I don't know when this came out, about a raw string, and you use this open parentheses and the closed parentheses there inside this. Anyway, and it lets you split your double quoted string up across multiple lines, and it's just nice. Yes. And now we should be able to do this, and then we would do the program.execute.out. Do I want to do this yet? No, but I will do program.execute. Yes, I know it's commented out. And then cout. No, program.out. And there we go. Let's see, what else do we need? We will need a pound include iostream, and just to make the purists mad. All right, so I'm looking for my Tang base to be able to be instantiated, to have a, and in fact, forget the auto. Let's just say that it's a program. So compile script is going to take in a string and give me a program, whatever that means. It's an object, but it's of type program. Okay. And from there, hopefully we'll be able to execute it, and then it should have an out that is a string of some sort. All right, so that's the goal. First of all, do we have, well, we need to create this program class. Because right now, I guarantee you, if we say make test, it's going to say, yeah, I don't know what program is. So include and program.hpp, and this is going to be, well, I'll have to see what all we need to include, but let's say namespace Tang, class program. It doesn't inherit from anything. Let's just give it an empty constructor at the moment. It's going to have, that's what I need to do. String called output, and it's eventually going to have an execute function. I don't think I need to, do I need to create that yet? I will just for the moment. It's not going to return anything. And it's not going to do anything. And does it need anything else? Yes, it does. It needs so when we're creating this program, it's not going to be an empty constructor. It's going to take in string, and we're going to use the word code. Why? Because script gives me the idea of this is meant to be executed. Template means it's a template style. And so the goal for this is to say, you tell me what style or what it's supposed to be. And in order to do that, we should probably I'm looking up something. I want to make sure I've got, like I said, I'm not copying necessarily something else. Yeah, let's try this. Wait. And what is it? What did I get? Code type, and we're going to say it is either a script or a template. Probably have to have a semicolon there. And now this is going to be a code type, and we'll just say type. All right. Inside, no, I'm going to do this in a CPP file. So, in fact, I'll do the same for the execute. Evidently, I don't know how to use Vim. All right, so there's going to be some sort of execute, and there needs to be a compile. Yes, I need a compile. But that should be private. All right, I think I like this format, and I'm going to use this other screen but I don't want to cover it up with my self down here, my face. So let's do this. Let's vim source / program.cpp. Yeah. And here, just open up the include program.hpp. That way we can see them side by side. Okay. So definitely going to need to pound include program.hpp. What do we say? Program. That's the constructor name, and it takes all right. We're going to also, in a private variable, store the code and the code type. Yeah. I think I like that idea better. So actually, I've never done it here. I'm thinking, I guess we can do code is going to be code, and code type is going to be code type. All right. At the moment, we're just trying to get this to compile, right? So I also know that I'm going to have a void Tang program execute. That does nothing. And a compile that does nothing. Do I have that? I've got my constructor. I've got my execute and my compile. All right. I need to edit my make file to add an object for these. So let's name this program P. This is program. And do I need location.hh for the moment? I don't think so. Add this to my objects. What is its name? Program.o. All right, and now let's see what. Does it not like? expected identifier before enum. So I've never used the class enum. From what I'm seeing just very, very quickly, we can have it just as a regular enum, and that should be fine. And now it needs a semicolon after the class. I always forget those. There we go. I was missing a closing brace as well, but hey, who's counting? Okay, so it compiles. That's always a good thing. Now let's do this. Let's also, in our make file, copy this watch command and create it for the test. Okay, so we'll just say watch dash test. I have a feeling I'm going to be running watch dash test significantly more often. Where's my phony? I need to add it to that. Watch and then watch dash test. All right. Make sure it's showing up. Watch dash test. Yes, I didn't change this one's font size, did I? Properties, I'm at 30 here. This needs to be 30. There we go. There we go. Watch dash test. So of course, did I change what I'm doing? No. Y'all aren't supposed to let me make stupid mistakes like this. We need to make test. There we go. Run that again. And now I'm okay with this. Program is not a member of Tang. Why not? Did I not pound include it? Well, let's go into it. And I know that there's a way to make Vim switch out the files. I haven't learned that yet. Or I knew how to do it years ago, and then I haven't programmed in Vim for quite a while. So, yeah. Tang.hpp, does that not include Tang test? So includes Tang.hpp. It does not pound include Tang test. No, I meant program. Okay. Now we've got a different error. That is Tang base has no member called compile script. We need to add that. Yes, that is right. Okay, so In the includes for Tang base, again, you can see all of the documentation that I have here. It needs a public function that is it returns a Tang. Well, I don't need to say that. It returns a program. Compile script, and it takes a string, and we'll call this script because it's specifically a script in this case. All right, and so we need program and a string. Include string okay. Redefinition. Why? Because we didn't put our guards in place. We can do that. If indef, and we'll just say all of our include files should have this, or it should have a pragma once. But sometimes this is more necessary. So that is the way things wire together. This may be, and if this may be the better solution. There, I don't like not having. There we go. Okay. Undefined reference to compile script. That's because we haven't written it yet, but. And this is our source / Tang base. And then we have here. There we go. And now it returns void. No, it returns a program. Compile script, and it takes in a string that we're calling script. And now we need to say what it does. Okay. You may be wondering why we've got this Tang base thing, by the way. And one of the goals that I want for this project is that when Tang itself as a library, it exists, of course, in that, or excuse me, as a language exists in that Tang base object. And I want other pieces of code to be able to plug into it and say, hey, I want to add functionality. Maybe I want to add date time functionality. And I want so they need to be able to access the underlying structure, and it will be through this object in the future. But for now, it's kind of like just a placeholder. So, yeah. So we might just be able to say as simple as return a program that passes in the script and oh, what did I call that? See, now I need another window. this is my temporary window that I have just to find out things. And I want to remember what I did in my include file for program, and I have an enum of code type. So, script. Does that do it? Alrighty. So it recompiled Tang base, recompiled the shared library, and now it can't open libtang.so. Why? Does it exist? That's a very good question. Build apps. libtang.so does exist. So now, let's see, what error did I make? Oh, 0, the include, build generated. My library is user lib, build /apps. It is in there. I think I have an extra period there. Unfortunately, this won't pick up the change, so I just have to remake it. That was it. So I cleaned it, which deleted everything, which means something didn't get recompiled when it needed to, which means I need to double check my dependencies that I list in the make file. But when I did a clean and then it did Bison, the AST error program, the Tang base, Tang scanner, then it generated the flex, Scanner.o. Do I have it in here twice? Oh, I have the wrong description. This should be parser. There we go. Okay, because that's what this was, compiling Tang parser.o, not Tang scanner. All right. And then it put together the shared library, and then it compiled our test using that shared library, and then it executed, and it did nothing because we're not doing anything. All right. So what should this look like? we're going for the source program.cpp, and we're going to compile. Say, could we put this here? Yeah. I'm thinking through how I want this to be called. There may be more work that this has to do, that the constructor has to do. But for right now, the compile. All right, now some things that I need to be able to use in order to do the compile and the parser and everything like that. So let's pound include, what do I need? I need a string stream. Yes, why? Because our parser needs a string stream. All right, I'm using my namespace standard. I'm going to need to pound include our Tang scanner and our parser. That might be it. So what should this look like? Well, first of all, we need to create a string stream. We'll just call it SS using the code. All right, that's just, we're feeding it in. All right. The scanner, we'll just call it scanner, its constructor takes the string stream as an input, and it needs an output stream in case there's an error that it needs to report. However, I happen to know, because I examined the source code, that it doesn't ever output an error. We could just create a phony string stream, but we could also just say use cout. That's the default, by the way, of the original program was use cout. So, but for now, I'll just do that. For our parser, then, we need to give it the scanner, an AST pointer, and an error pointer. So that means we also need up here a pound include AST and pound include error. Okay, and we kind of need to what will AST and error be? These need to be private variables. So it really should be this arrow AST and this arrow error. And these are supposed to be pointers, and that means, yeah, I think that we're going to sorry, I'm arguing with myself. So I think we can remove these two actually. Why? Because so AST and error. If we edit the program, is something else open? Yes, I opened another window. Let me close that window. It's closed off screen. Okay. And I said, do we do it as a private? Yes, we will do it as a private. And it will be... Now, I'd already said that we can't create an AST node because I made that protected. So it's going to be a pointer called AST, and error will also be a pointer called error. So these may not exist. And why is this not working? All right, and I said AST, we're going to say, can we do this? I don't know. Null pointer didn't exist when I started out. No, I'm not sure. All right. Let's see. Where is the... Here it is. You wonder why I put the green thing here? It's so that we can scroll through easily and find it. Okay, so it doesn't like when compiling program. AST does not name a type. It's an AST node. That's why. Gotcha. Okay, now redefinition of AST node. Why? Because I did not put the guards in. That's fine. We can fix all of these. Why prefix it with Tang? Because maybe something else is using AST underscore HPP. And I probably have to do the same thing with error. Oh. There we go. And error is redefined because we need to put the guards in. Error.hpp, and this is going to be a pound if not defined Tang error HPP pound define. There we go. And then okay, it's compiling again. Now, where were we? We were in our program.cpp, and we were saying, okay, so we've created a string stream based on the code. We are, the scanner is based on the code and cout. Okay, that's fine for the output. And then our parser is based on the scanner, and then the this arrow AST and this arrow error. So the intent is that the parser, if there is an error, it will put it into this arrow error, and if there is an AST created, it will put it there. All right. So now parser.parse. That's what it should be. It compiles. And now our test.test, we're compiling it. And now I want to know, is there something in the AST? But that is protected. So I'm going to be a bad boy and make it not protected for the moment. No, I'm not. I'm going to go ahead and in the include program, I'm going to give us a function that will be return a string, and it's going to be get program. It can be const. Oh, okay. Now I've got to remember how to do this. I'm going to have to look it up. We're going to use an optional. And it is, I need to know what class to include. Hate it when I do that. Oh well. Optional. All right. So now it's going to return a standard optional of an AST node pointer. Is that going to work? I think so. And we will call this, say, what's the point of giving it a pointer if, or making it protected? It makes me sleep better at night. For right now, a pointer to a const AST node. How about that? That should work. No complaints yet. Okay. So get program and get AST. So we're going to do our get program returns a string. And we should say I should call it get code instead of get program. And then the last one returns an optional const ast node pointer, and it is get the ast, else in case you're wondering, it's like, how do I return an optional that doesn't point to anything? Oh yeah, yeah, yeah. That's right. It's null opt. Oh, std : but this should work. Actually, the question is it going to let me do that? What's it not like? No declaration matches standard string. Okay. Oh, get code, because I changed the name. Of course. And I think it's not watching the headers. Oh wait, no, it did. I think when maybe I click on it and it maybe I hit the scroll log. That Control S will freeze the screen, Control Q will unfreeze it. But we're good so far. All right. What do I want to do with this AST node? Well, I want to dump its contents. So, we should have, so there's an inspect, but I don't think that is a good word for it anyway. So now it's going to return this as a string, but ultimately it's going to be a big block of text. But let's say I'm just going to call this dump, and it's going to need a string called indent. Can I do that on a virtual? So dump, and then AST node will also need this exact same thing. Not include source. Yes, I'll figure out how to open multiple files in Vim. I'll do that soon. So now instead of inspect, this is dump. That's right. And there is a string called indent. Why? Because all that we're going to do is return a new line. And here, it's going to be indent plus okay. Oh yeah. I'll just say, even though that's not necessarily what we need, and then this should also be oh yeah, it's not inspect anymore, it should be dump. Okay. Closer. Now we're going back to our test. And I want to see out the program.getAST.dump. I shouldn't need the inline because they should be putting an inline after each of those. Is that right? Yes. This may not be watching the test directory as well. Has no member named dump. That's right. So getAST is an optional. So we're going to say auto AST is equal to program.getAST. If AST, that means if it exists, then we will doing the arrow should resolve it. Dump and then I'm going to change this so that the these both include move source include bison flex. And can I say test and make file? Okay. Now maybe it will run. Dump. Let's see. Error requesting dump. Is it because I did not mark it as const? Potentially. In the include /ast is dump is not listed as a const, which, since I'm returning a const, requires that I can only use but either way, that's not the error. So, um, I'm missing something. So it's not liking that I'm doing AST arrow dump. And I know that for an optional, how do you get at the value inside the optional? Because an optional is a container of something that could be there or not, right? And so this is, that's why it is an optional to a pointer. So I still needed the consts, but let's go back to our test. And unfortunately, so the first arrow will give me the pointer, and now I basically need to do another arrow. So the there we go. Nope, that is not what I meant to do. I probably hit the shift key. Yay! All that. You see, these first lectures are all about needing to lay all the groundwork, right? And so, for example, today had to lay the groundwork. What's a program? What does it store? You know, what are we parsing? By the way, this is proof that we're parsing. We get an AST node that includes an integer 3. And if you want me to prove that it's something different, then I will change this to, 42. And this is probably, I highlighted. There we go. Integer 42. If I change it to, oh, it won't handle a negative yet because I didn't put negative into the grammar. Into Flex. I didn't tell Flex to expect this. So it's not going to output anything because it's probably not going to generate an AST. In fact, oh, it did recognize 1, 2, 3. That's right, because in Flex, in fact, this is worth me showing you. Where's my other window? Not that window. There we go. So if we look at Flex itself, CD, no, I can just go from here. The scanner. No, there's a lot of stuff here. But if we look at the rules, first of all, I said 0 through 9, right? These are the numbers. And it recognized 1, 2, 3. But I said anything else, just skip it. So it saw the minus sign, didn't know what to do, so it just skipped it. So we can handle that, right? We can say, when I see something else, something that's unrecognized, do this instead. But I don't want to do that on like white space, right? If I have a tab or if I have a space or a new line. So like the new line, that's safe. But anyway, so right now it's ignoring the minus because it doesn't recognize it, and I didn't tell it what to do when it doesn't recognize anything, so it just kind of turns the other way. Okay, that's fine. Well, it's not fine, but we'll fix it in the future. But hey, that was a good thing to catch as well. But yeah, right now it is. I promise we would get where we could see that yes, it is. It takes a 3 and parses it, and we don't have the execute yet. That's probably going to take. I don't know how long this has gone on for. A little over an hour. We'll have to do a part 2 where we, because again, it's all groundwork, right? So for the next part, what we're going to have to do is we're going to have to say, okay, well, if this is a program, what does it mean to compile that into a bytecode? Bytecode that's made up of individual opcodes and the operators that it operates on. Yeah, we're going to have to do that next. And then what does it mean to execute it? So what's coming up is really the essence of our virtual machine. And even just on one little thing. Now, by the way, if we get it all working, then when we add a float, well, that's really simple. We just have to add the pattern to Flex, tell Bison what to do with it when Flex says, hey, I got a float. And it's going to be very simple, similar to what it does with an integer. And then create an AST node for it and say, okay, how do you print it out when we're inspecting it? Or how will we execute it? And so it's really simple to start adding on to this. It's the underlying structure that can take so long. And of course, you're seeing me do it live. I'm not copying and pasting, but it's so that you can see my own thought process and see where I'm messing up. Even if something as simple as, why isn't this AST working? If it's an optional, because I wasn't thinking, oh yeah, it's an optional to a pointer that you also have to dereference. And the dump, if I didn't have the const there, in fact, I might as well show you. If I did not have the const there, I probably need to do this in two. Yeah, I'll do it in both. It may not complain if I don't have the word const here. Yeah, it's not going to complain, but I'm going to have to put const in both places. Good, that's good to know. And now in the include.ast, I'm going to there we go. Save it, and now what it's going to say is, this is the error I would have gotten if I hadn't have made that change. I'm passing a const AST node as the this argument, but dump isn't declared const, and so it's saying, hey, this AST that you're dereferencing, right, with the arrow, it's calling dump, but dump doesn't promise that it's safe to use with a const. So that's what this const identifier is. And so, okay, there, put it back. And now I need to put it back in the source/ast. const gives a lot of students a lot of problems. And because they're like, if I just leave it off of everything, everything just works. And it's like, yeah, but your code isn't as safe. It doesn't give the guarantees that the compile time guarantees that you want to use. So when you start adding const in one place, that there's often a waterfall of, or a chain reaction of, oh, now I've got to add const here and here and here, and it's a headache. You know, your code might not compile forever because it seems like all of a sudden you're having to put consts everywhere, and then if you back yourself into a corner that something can't be declared constant. So we start off now, right at the beginning when it is safe. That's why I'm going to go back to this. In the program, I said source, but I want this as the include program. This AST node type, my thought was it's private, right? Because I need to be able to access. That is the program class needs to be able to access it. But I want to be able to give that out as a pointer, but for the person not to be able to modify it, right? I don't want them to be able to play around with my AST node. And so I say, I'll give you the pointer to my AST node, but it's going to be a const, right? And of course, for all of you C++ people, you'll probably know that I could have put the const either before or after AST node, but there is a difference between. Okay, so const AST node star versus AST node const star. Those are exactly the same, but it is not the same as AST node star const. Yeah. And there's also AST node const star const. And you just have to, you can look them up as to what the differences are. In short, this is the correct one. And if you're dying to know, I can go into the others, but it doesn't make any sense to return a constant pointer to a constant AST node, which was the last one that had constant there twice. But anyway, yeah, all of that is to say, we're there. We're at a stopping point. Let's see what all we changed, shall we? What all have I done? There we go. So our get status, we changed our make file. What did we change in our make file? In the make file, we that's right, we added the compiling for our new program class, and so we had to add the rules for it. I changed a typo, and I added our first, I'm calling it a unit test. These are not unit tests, what I've done so far right now, just trying to get something to compile and run. But we will actually start doing unit tests. But first I'm going to get a single actual compile and execute working, and then we'll start the unit test, and then we'll start expanding the language. All right. And I added an additional watch and a test rule. Okay. What else did I do? In the, let's just do this get diff all the way around. Here we are in our AST dot. Did I put? I never want white space, and I know there's a get rule you can use to tell it to ignore white space at the end of the file, but to me, if you're doing that, you're doing it wrong. You should just be disciplined You should not make stupid mistakes like that. But I made a stupid mistake. So vim include AST and that was it. All right. So we changed this inspect thing to a dump where we can give it an indentation. Why an indent? Because later, an if statement, it's going to have an if, and then you'll want to give the body of it, and maybe there's an else, and you'll want things indented so it's easier to read. All right. We put guards in. Let's see. Our Tang base, we added our compile script. Yeah, that's it. All right. So what I'm going to do now is I'm going to finish up documentation. And then for the next time, we'll plan on doing writing the compile and virtual machine execution logic. That's another big one. But these are all at the beginning. They're all big. So anyway, all right. Well, again, if you've made it this far, you're a trooper. Thanks for sticking with me, and I hope you have a great day. Bye.